Okay, so in our last video we added a strategy into it. Now we pass it into our constructor and set it to the strategy in the contract. We also updated our total assets function so that it accounted for the assets that we pass over to our strategy. Now this was the accounting done if tokens are passed over to our strategy, but we didn't actually implement the logic to do that passing within the contract. What we're doing is we're doing it in our tests instead. Now in this Transmissions 11 Soulmate implementation, he has actually put some internal hooks at the bottom of the contract that we can then implement. So we have here before withdrawal and after deposit. And what we're going to do is, I might just take that actually like this. We'll just take it like this. And before withdrawal, I'm going to put this here. Yeah, let me go there. Okay, and we'll just get the after deposit one as well. And after deposit. Okay. So what these functions are going to do is after we call deposit, so we call our underscore deposit function on our contract, and it then calls this on the ERC20 or ERC4626. I'll click in here. So here's our ERC4626. What happens then is after everything is done here in the ERC4626, it calls this internal hook function, okay? And that's a virtual function, so we're going to override it with the logic that we want. And the logic that we want, after somebody deposits into the vault contract, essentially all we want them to do is we just want them to send those tokens or those assets over to our strategy contract. So what we're going to do here is, it's pretty basic, so after deposit, we're just going to say asset.transfer. So they're already in the possession of the vault. And we're just going to say send them to the strategy. And we're going to say it is assets. So, and that's all that we're going to need. So that's pretty much just any time after deposit is called. So as I said, when somebody deposits into the contract, at the end of that function, you'll see that this is called after deposit. And what we're going to say is actually send any of the assets that they've sent over to the strategy contract. Equally, when someone withdraws, and I'll just say that I've actually changed this, the withdraw is our function, but I've changed this from the internal withdrawal one, I've changed it to redeem. And the reason for that is that withdraw takes in assets and redeem takes in shares, and we're going to be redeeming shares in our implementation. I did have it set to withdraw, and it didn't really matter from from the point of view of doing our tests because it was kind of like for like. But now that we're doing it with the strategy, I want to have it as redeem. So you're redeeming shares for assets rather than assets. Okay. So go back over here. So for the before withdraw, again, that's in our redeem function. You'll see here that that when somebody redeems before withdraw, we're going to call out to the strategy contract and say, give us those assets back. Give us the amount of assets that they are due from based on their shares calculation, and then take them back over to the contract and then send them out to the user. So what we'll do is we're going to do asset, and it's going to be transfer from the strategy to address dot this, and it's going to be assets. And that should do the trick. So there's the two hooks. Essentially all they do is when we deposit, we send the assets over to the strategy, and when somebody withdraws, it takes them from the strategy back over to the vault implementation so that they can be sent to the user. So we're going to switch over to our tests. I have already put a couple of things into the test here, so I'll just go over what I've done. One of the main things I've done in our setup function is I've VM start prank as the Aave strategy, and I've said that our vault is allowed to transfer, is approved to transfer a large amount of tokens over. And the reason for this is we want to approve our vault to use the tokens from our strategy, so transfer them back when before withdrawal is called. Okay. I've removed the zero address test because that was no use. I'm going to just show you something really quick here. So because we've implemented this after deposit function here, okay, this is kind of redundant. This part here where it transfers them over. I'm going to run the test and just show you exactly what I mean. So if we go forge test -- match test, do this. we're going to get like an arithmetic overflow or underflow error here. There we go. So we're getting when we do the USDC transfer here of the 50,000, we're getting an arithmetic underflow or overflow, underflow or overflow. And the reason for that is that no longer when Bob deposits 100,000 tokens in, they're just going over to the contract straight away. Same for Alice, 60,000 they're going over to the contract, and the same for Carol, 240,000 are going over. So by the time it hits this, there's no tokens left in the contract to transfer over. So that part is redundant, or it can't be used anymore. So I'm going to take this out, and once I take that out, this lifting here for the strategy for adding tokens to the strategy is already going to be done here by the deposit functions of these helpers. Okay, so if I go back in here, try this one more time, you should see that this passes. Here we go. Yeah, and our test is passing now, so that's fine. What I'm going to do then is we will just do one test for the, what we call it, function test, and we say after deposit public. I think they're called after deposit. Let me see. After deposit, yep, that's fine. So what we're going to do is we're going to deposit USDC as Bob. That's 100,000. Then we deposit USDC as Alice, and we'll do 400,000. Okay. And now what we're going to do is we'll do uint 256, and we're going to say USDC balance of vault equals, and we go USDC dot balance of, and we're going to say vault. You might need to wrap that to me. Yep. Wrap it as an address. Okay. Then we say uint 256 USDC balance of strategy equals USDC balance of strategy. This should be an address, so it should be fine. Oh, wait. Oh, actually, it's called Aave strategy. Okay. And then what we'll do is assert equals. We're going to say USDC balance of vault should be 0. And then assert equals USDC balance of strategy should be 500,000. That's correct, 500,000. Yep. So this should pass. So copy that, because what we're doing is when Bob deposits 100,000, it immediately sends it over to the Aave strategy. And as Alice deposits 400,000, it then immediately sends it over to the Aave strategy. So the vault should almost straight away after the deposits, it should have 0 tokens in it, and the strategy should have all the tokens. So this is what we're hoping that this test pass. Both of these asserts should pass. So we go forge test, match test. Just get the stack and see if it passes. Cool. Yeah, that's passing. Okay, so you can see here the balance of our Aave contract or strategy that we're calling it is the 500,000, and there's no tokens at all in the vault. So that's it. It's just a way of using these internal hooks that are implemented in the Solmate. Again, you could write these yourself. There's no need to use if you're using a different library, you can implement them yourself. But I just use the before withdrawal and the after deposit ones to show you how you would actually hook into your strategy contract and to make everything coherent and that it works with the shares and the assets being redeemed. So this is the last part of the ERC4626 video. I'm not going to go into doing a full strategy for these 4 videos, but what I might do in future, I wouldn't mind doing something like implementing a auto compounder, so people can put their LP tokens into a vault, and then the vault will put them into a liquidity pool, get the emissions in, and swap them back into an LP and stuff like that. So I might do that in future, but for now this is the end of the 4626 video. I hope it helped.